Hello everyone. Today I'm going to be giving you a microhistory lesson on how truth tables came to be, showing you how to use and solve simple truth tables using 1 and 0 values with binary system and true and false values. I'll also be showing you a program that I've made in Ruby that solves truth tables for you. So let's get into it. So to start, I'm going to give you a micro lesson on how truth tables came to be. Truth tables use something called Sential logic, which was developed in 1897 by Goltbart Frege. I don't know how to pronounce that, but that's my best guess. The truth table system was created by Charles Peirce, an American logician. Truth tables can be used to see how truth values work in comparison to different sentences. So a conditional statement, if apples are red, then oranges are orange. A converse statement, if oranges are orange, then apples are red. An inverse statement, if apples are not red, then oranges are not orange. And a contrapositive statement, if oranges are not orange, then apples are not red. Another use of Sential logic is syllogisms. Here are two examples. All mammals are animals. All elephants are mammals. Therefore, all elephants are animals. This is a valid syllogism. And an invalid example would be, anyone who lives in Texas also lives in the United States. Bob does not live in Texas. Therefore, Bob does not live in the United States. But, if you know, there are 49 other states in America. Bob could live in North Carolina, or Ohio, or California, and he would still be living in North America. So this one is invalid. Now, I want to give you some simple examples. So to start with this table, usually in the first two columns we have P and Q for simple truth tables. And P is assigned 1, 1, 0, 0, and Q 1, 0, 1, 0. Once you get into larger, more complicated truth tables, there are certain rules to how each of these are ordered. And I'll link a website that helps describe this in detail in the description of the video if you're interested, but I won't be getting into that. If you know anything about binary logic or binary computer system, 1 and 0 are the only values. And 1 is equal to true, 0 equal to false. A good example I hear all the time is a light switch. On would be 1 or true, but when the light switch is off, it's 0 or false. You can also have not values, so not P and not Q, or the equivalent of true false to 0 1 values. The exclamation point is not the traditional symbol to issue not in truth tables, but I couldn't get that symbol in PowerPoint, and for the use of my program, I used the exclamation point for simplicity. Exclamation point is commonly used for not encoding. Some more advanced examples are P, Q, not Q, and P and not Q. So when you have and terms multiplication. So like 1 times 1 equals 1, which would be true, but 1 times 0 equals 0, which would be false. So if you go through, but 1 times not P, so it would be the P here on the first column, and then the not Q. Let me see. Oh, I have a laser point. Cool. So it'd be 1 times 0 would equal 0. 1 times 1 equals 1. 0 times 0 equals 0, and so on and so forth. And you can set the true false values. There's another type of things that's commonly used, and that's OR. OR stands for addition, as subtraction and division don't exist in binary logic. So OR would be adding. So 1 plus 0 is 1. 1 plus 1 also equals 1 because in the binary system there is only zeros and ones. There is no such thing as a 2. So you can just, if it equals 2, it always equals 1 or true. 0 plus 0 is 0, and 0 plus 1 is 1. So in this example, there's only one false statement instead of one true statement, where this one actually should be up here, not circling the false. So more advanced examples would be like this, not P and P or not Q. So you would solve within the parentheses first, so P or not Q, which was solved in the previous one, and then you would take that value. So let's say, in the example, 1 plus 0 is 1. So that'd be 1 plus, or times, because it's and, not P, which is 0. So 0 times 1 is 0. And you can keep working out, and you can do the same with true-false values. In my program, I will only be doing the simple ones of if P and Q, P or Q, or so on and so forth in the iterations. I'll show you when I get to the program. And then you just pause the video and read this if you would like. So if you would like, here I'll have a download in the description for some examples if you would like to mess around with it. And if you go to the next slide after this one, the answers are there. So without further ado, let's go to the program. So this is the program. You don't have to read through the code if you don't want to. If you understand it, you could try. Don't yell at me in the comments that I did a terrible job about coding this. I know there is a better way to do this, but I've just started learning this language, and this is actually the first program I've ever written in any language, period. So I say it's a good feat to start. So to use it, I'll have this link in the description. You click the link, and you're going to click this run button. And this is going to run the code. It might take a little bit longer depending on your internet connection or whatnot. I don't think you need to sign in. You should be able to. I'm not signed in. And then just kind of read through these rules. Make sure you understand them. Read the license file if you want to use the code in your website or your program. And then once you're done, type yes to move forward. If you type anything but yes, it's going to loop through, so you have to type yes. So type yes. And then, so column 3, I showed you there's like P, Q, and then not Q. And that's the third column, not Q. So that third column could be any of these values. P, Q, not P, and not Q. Anything else, it'll just loop through. So like if I was to put H, it's going to be invalid input. The program only understands P and Q values, or not P and not Q. So for this instance, I'm going to do not Q for the one of the better examples. For column 4, which is the last column, these are the only valid inputs, and you have to put them in a very specific way. So for instance, P, comma, and comma, not Q. This will be fine. You could replace and with or not P, or not Q with not P, and switch P for Q, whatever you want, as long as it stands within these parameters, each thing. So like, this needs to be just P, not P, Q, or not Q. Then there needs to be a comma. Then there needs to be and, or, then another comma, and then any of these values again. It could be the same value if you wanted. You could do P and P, but I don't know what the point of that. Then once you're done, you can click enter, and it will evaluate the table for you. Not all iterations will have the table lined up perfectly like this. Sometimes this will be in. I'll show you in a second. If you want to restart the program, you can type yes, and it'll just loop through the same thing. So this time I'll do an or. So not Q, P, comma, and or, comma, and not Q. And you see how it doesn't line up, but it evaluates for or. As you can see, it's false, true, false, false, and now it's true, true, false, true. And you can keep looping through the program as long as you want. If for some reason it breaks, you can just hit the run button again, and it'll just completely restart the program. Or if you want to exit, just type anything but yes, like no, and the program will end. If you have any questions, you can put comments here if you want. I don't know if I'll see those. You can put comments on the YouTube video, or, well, those are the only two places I think you can put comments. But feel free to use this or edit it if you would like a challenge. If you know the language, just make sure to put my, where is it? My information by the MIT license, which I linked. If you're logged in, you'll be able to see all the files and just read the license file. So I hope that's helpful and you can use the program.